Tipi Phyre.
There are many kinds of fire structure form variations, but the only one a firekeeper really needs to know is the Tipi structure to clarify and understand all the principles. From that point on, a firekeeper can do any safe design fire they wish. First, we need to clarify the principles concerning wood fuels. Fuels, by definition here, as you probably guessed already, are life-supporting wood products to sustain a fire. 1. Safe gathering. 2. Non-toxic. 3. Stores and reserves. 4. Dead, dry, and not green. 5. The chemical makeup. 6 is wood hardness. 7 is the sizes. So the first one, gathering wood fuels, may require that you have to break pieces off or up. Don't climb trees unless absolutely necessary. Don't break wood over your knee. Use the crook of a tree or the like. Careful bashing wood for flying splinters. Don't place yourself and others unnecessarily to accomplish this task. Larger pieces can be burned in half. Second, through plant and tree identification, you should know to not collect or burn anything toxic, like poison ivy, oak, or sumac, and the like. The firekeeper is responsible for the education of other persons who have the task of collecting wood fuels. Third, always collect more than you think you need, and keep it dry and available, especially for through the night, if necessary. No one should ever go gathering at night. Fourth, dead, dry, non-green fuel burns best, with the least amount of smoke and steam. Gather fuels high off the ground during wet weather and in humid places. The different ecosystems will determine and guide your gathering. For example, collecting in New Jersey is much different than Southern California in summer. Also, in the Northern Hemisphere, a firekeeper gathers on the south side of places which have longer exposure to the sun all day. Standing dead material will be drier at the top than near the base, which is closer to the ground, and humidity absorption. In cold weather, it can be harder to determine moisture contents of fuels. A snap test or touching it to your dry lips can help. Fifth, knowledge of chemical makeup of certain fuels may help with fire ignition even when wet, and we'll discuss this more later. Sixth, wood fuel hardness can be important to know for a few reasons. Now, softwoods like evergreens burn hotter and faster. Hardwoods like oaks, walnuts, and hickory will create coals that burn longer. You may need to keep this in mind when using the fire for tasks like cooking or tool making. And medium woods, of course, are in between. Seventh, there are many sizes of fuels that a firekeeper needs to understand in order to create a tipi structure. There are about 7 size variations we need to clarify. The first 3 are really the most important to a firekeeper to create a fire. The first size is coal extender. This is a powdered form of wood fuels that will hold a coal ember. The principle is the same as a burning cigarette. Now, some examples are the funguses and the punky wood shown in the transporting of fire. Another example is dried herbivore scat, if a firekeeper doesn't mind touching it. Another is leftover dust from a friction fire method, which we will see later. The coal extender is added to the coal ember and dust created by the friction fire method with the purpose of enabling the ignition of the next size fuel. Second, tinders are giant balls of fibers used for transitioning a coal to flame. Some sources can be from the previous list of plant and tree cordage materials. Another source is seed down. Famous ones are dandelion seed heads or cattail heads. Others are from milkweed and dogbane seed pods. Now, warning, down is highly flammable, almost like flash paper. Now, a tinder bundle shouldn't be made entirely of down because it won't hold a flame long enough to ignite the next size. Some other down examples are reeds and thistles. Now, dead and dried grasses and mosses can also work excellently. Now, what not to use for tinder? Don't use dryer lint. It's full of chemicals and can create a toxic smoke. Do not use hair. Animal and human hair is oily and will only singe down anyway. Do not use mouse nests. Hantavirus is a very real and dangerous disease which can be acquired from just being near a nest. Avoid at all costs. Again, be careful of hairy vines. Make sure you aren't gathering poison ivy and its family or anything else toxic. Tinder can also be created by pounding wood fibers between two stones from any dead, dry branch, bark, leaves, or pine needles. Tinder is necessary to ignite the next size fuel. Third is kindling. Is any wood fuel up to about pencil size. These are usually sticks, plant tops, or large grass stems. These are the first layers of the teepee structure. To assist in the ignition of kindling, especially when humid and full of moisture, there are some wood fuel options whose chemical components make this much easier. One is pitch sticks, or fat wood. These usually come from old stumps of evergreen trees that are full of pitch or sap. The sap is chemically volatile and will burn even if wet. Another is birch bark. Some barks are saturated with natural oils. These barks also can come off in convenient sheets. They can also ignite when wet. Fourth, finger-size fuels are next, whether they're sticks or chopped pieces from logs. Fifth is wrist-size fuels. Sixth is bulk wood fuels. Seventh, whole logs are the last size. These are usually unnecessary. Again, cutting the logs can be done by burning in the fire. Other natural fuel types can be large herbivore animal scats. Some native peoples will burn these instead of wood, such as buffalo chips. In order to ignite the next mass size, each smaller mass size is placed before the next. Fuels within the teepee structure also need to be densely packed together. Again, I will use a life form comparison for this reason. At the stage of igniting, the fire is still in its infant stages, and you can't expect an infant to get its own food. The fuel layers, like an onion, should be so closely packed together that you cannot see the layer underneath. This helps ensure the next layer's ignition. The teepee structure, true to its name, is a conical-like structure with a doorway entrance to its center in order to receive the ignited tinder bundle. There are 7 very good reasons why the teepee structure is the one to know and understand first and to use most of the time. First, because of its conical-like structure, each outer layer gives protection to the inner layers from precipitating elements, especially when you're trying to ignite it. Second, because of its close layering, it is completely self-starting, self-igniting, and self-feeding after placing the lit tinder bundle inside. Third, because of its conical-like structure, it will create a candle-like flame which will give off the most light. Fourth, that same candle-like flame will also give off the most heat. Fifth, because of that conical-like structure, it creates a natural chimney updraft and creates the least amount of obstruction to the fire, giving off the least amount of smoke. Sixth, the teepee fire has the ability to burn down the fastest, creating a bed of coals for uses like cooking. A bed of coals is a mature fire in which you only need to add fuel to it to keep it going. Seventh, the teepee structure is the easiest to build up and feed. The firekeeper only needs to lean more fuel in the empty spaces as they open up. Now that all the foundations have been clarified, we are ready to create fire by wood friction fire methods, techniques, and designs.